This video is going to show you the solution to a in-class worksheet problem involving capacitors. You were given the capacitor circuit on the left, and what you were supposed to find was the equivalent capacitance, the charge residing on each of the original capacitors on the circuit on the left, and the voltage used up by each capacitor called the potential difference, as well as the energy of the final capacitor. So to begin with, I've done the first step here where I've solved everything down to a single resistor. And I did this by following steps. First, the 3 and the 6 microfarad capacitor are in parallel. And in parallel, you just add them up to get the total capacitance. And so I replace them in between the junctions with one capacitor, a 9 microfarad capacitor. In the next step, going from the middle to the last step on the right, what I noticed was the 2, the 9, and the other 2 are in series. In series, the inverse of the answer is the sum of the inverses. So a half plus a ninth plus a half is 10 ninths. But then I've got to flip that to get the answer. So I get 9 tenths or 0.9 microfarads. So now for this last capacitor, I know what the voltage is. It's 9 volts because that's the battery. And I also know its total capacitance of 0.9 microfarads. Now I need to find the charge. To find the charge, I'm going to use my definition of capacitance. Capacitance is a ratio of charge to voltage. And I'll solve it for Q and then plug in my numbers for this capacitor, the 0.9 microfarads and the 9 volts. And that gives me 8.1 microcoulombs. So in this last capacitor, the single equivalent capacitance, I have 8.1 microcoulombs and 9 volts. Now, my original goal is on the left, is to find the current on each capacitor on the left and the voltage used up by, or the potential difference, for each capacitor on the left. So now I've got to work backwards from right to left. So as I look at this, I've got the 9 microfarads, and that 9 microfarads is made up by these three capacitors in series. And I know in series the current stays the same. So I take the current of the capacitor that they made, the 8.91 microcoulombs for the 0.9 microfarad capacitor, and I copy it. So each one of these uses 8.1 microcoulombs. So for each capacitor, I now know the charge on each one as well as its capacitance. The next step is to find the potential difference, or the change in voltage used up by each capacitor. So I use my definition for capacitance, C is equal to Q over V, solve it for delta V, and plug in my numbers for each capacitor. So for the 2 microfarads, I'm using the 8.1 microcoulombs. For the 9 microfarads, 8.1 microcoulombs, etc. So I get 4.05 volts, 0.9 volts, and 4.05 volts. Next, when I look back, I can see that I've got a 2 ohm microfarad capacitor and another 2 ohm microfarad capacitor. They're the same capacitor. So I'm not going to do any math, I'm just going to copy those numbers over. Now I've got to deal with the 3, the 6, and the 9. Well, I know that the 9 was actually made up of a parallel combination of the 3 and the 6. And in parallel, the voltage stays the same. So what I'm going to do here is take the voltage used up by the 9 microfarads and copy it over for the 3 microfarads and the 6 microfarads. So in parallel, the voltage stays the same, so I'm going to take my voltage of the resistor, or the capacitor that was made, and copy it backwards to the other capacitors. Now I have those voltages. In the next step, I'm going to use my relationship for or definition of capacitance, C is equal to Q over V, solve for the unknown variable, which in this case is going to be the charge. So I know that the charge is equal to 3 microfarads times 9 volts, or 0.9 volts, to give me 2.7 microcoulombs. And in the next capacitor, I know that 6 microfarads times 0.9 volts gives me 5.4 microcoulombs. So now for each of the original resistors, I have the charge residing on them and the voltage used up by, or what's called the potential difference for each capacitor. So I have total capacitance of the circuit, I have the charge and voltage for each capacitor. The last thing I had to do was find the energy. So to find the energy in that last circuit, what I'm going to do is take a look at its capacitance of 0.9 microfarads and its voltage of 9 volts, and use my formula for the energy stored, where the energy is equal to 1/2 CV squared. So that's equal to 1/2 0.9 times 9 volts squared, which gives me 36.45 microjoules, and that's the energy stored in that last capacitor.